This is for global server load balancing with NS1 and NGINX, and I'm here with Damian Curry. My name is Monica Miller. I'm a solutions engineer at NS1. I specialize in DNS and application delivery. Prior to this, I worked at OpenDNS and was an original employee. So if you have any security concerns or any application delivery concerns, come talk to me after.
Yeah, and I'm Damian Curry. I head up the technical side of the partnerships here for NGINX, now part of F5.
Yeah, so we're going to talk a little bit about NS1 and NGINX and a really awesome opportunity that we've had to work together, and we're excited to share it with all of you. So just a little agenda. We're going to be heavy on the NS1 content. If you came to learn about DNS and you came to learn about all of the awesome things that we do with DNS, you're in the right place. So we're first going to talk about sort of our place in the market and the opportunity that we saw several years ago. Most of our co-founders, kind of came into the space with CDN knowledge, with knowledge of working at other infrastructure companies, and they were able to sort of see a lot of the gaps that have presented themselves over the last 30 years in internet technology. And so one of the things, you can see in 1983, obviously in Berkeley, we, invented the DNS protocol. It basically was able to enable everything to talk on the internet. For the one person in here who doesn't know what DNS is, the way that we refer to it is the phone book of the internet. Everything has an IP address and talks to each other. And so as we kind of went through sort of this explosion of the .com boom, all the things you guys are familiar with, we had a lot of use cases based around bind. And it was a open source technology that some of you in this room may still be using today. You may have used it in the past at other jobs. And we, a lot of, as RFC kind of, graduated and there became more rules, a lot of vulnerabilities got introduced in the process of this. And so that's where we sort of start to see managed DNS providers really coming into the space. Neustar, Infoblox, Dyn, as you're all aware of those individuals, they base a lot of their technologies off bind. And so people started sort of migrating a lot of what they were doing, with a box in a server rack somewhere, to a managed DNS provider. And really in the late 2000s, when we were sort of seeing applications kind of explode with, the advent of mobile technology and a lot of other things and, things that you're using to just accomplish internal work, we saw sort of the proliferation of the need for a software-based solution that was performant. And so that's where you see Akamai come into the space as a really big provider. And so where we're at today is we have sort of this unique opportunity to utilize level 3 as a critical path protocol to be able to deliver applications faster. Think about it. Everything that you're doing at layer 7 is really important, but all of the things need DNS to talk to each other. And so our co-founders decided to create a company that was utilizing DNS as sort of application delivery stack that is for the modern enterprise. And so as far as our product portfolio, we're extremely diversified in what we've been able to accomplish in about 5 years. Our managed DNS platform is what we're going to be talking about today. It's our external service for all of your end users that may be requesting your applications and utilizing your services. Pulsar is our RUM steering engine, or active traffic steering engine. We utilize latency-based routing to respond with the best resource at the time, whether that's a third-party CDN or something that you're running yourself. We're going to talk a little bit about that with some of the examples that we have later. Our domain security suite and dedicated DNS products are really to address DDoS attacks and the ability to provide multi-provider redundancy, all while having a cohesive end-to-end traffic management policy that will kick in if for some reason your primary goes down. As some of you know, if you're working with multiple managed DNS providers externally, logic doesn't always translate. Everyone has a different way of putting forth geo, GSLB. A lot of the individual pieces of that don't necessarily translate cohesively, and so this is our response to that. It was actually created in lieu of the 2016 Dyn attack, where half the internet went down. Most of you probably remember. And so we decided to create a single tenant solution where we could create a customized POP network for you that would kick in at any point if for some reason our managed net went down. You have the ability to do vanity name servers and utilize it as a secondary. And it fully has DNSSEC, end-to-end signing and validation, which is a huge thing that a lot of providers in the space can't offer. In addition to that, our managed net covers 25 POPs globally, but we have a 4-POP network within China. This is really utilized for .cn domains, things that you may need to run locally there. And this allows you to do traffic management within the region without requiring someone to go out to, say, Singapore or Hong Kong or Vietnam to resolve their request and add on all that latency. We have a ton of customers, like individuals using this today to deliver their .coms, no matter where anybody is in the world, including China. And recently, over the past year, we've had a huge push from a lot of our enterprise customers to package all of this technology, all of this traffic management, all these traffic management pieces and the ability to kind of steer things appropriately behind the firewall. And so private DNS was released last year. It is a self-hosted solution that's fully comprised of Docker images that basically are deployed easily with a few composed recipes. You can get it set up in about 10 minutes. It's easily extensible and it's fully programmatically managed. And then we have our enterprise DDI solution, which was released last week. And so that's going to be DHCP, IPAM, and DNS. And that is also software-based only, doesn't require any appliances, and will work with a lot of the other components that are in your internal network. And so that brings us here. So this is the official kickoff for our partnership. We are very excited, whether you're an F5 employee in this room, an NGINX employee, or just a customer. We're really excited to kind of share this with you and birth this sort of natural partnership that I think we're all really excited about. And so really what we want to drive in this presentation and with this integration is the ability to automate and kind of use APIs to their best ability to be able to deliver the most responsive, healthiest endpoint to your end users. And we really want to have sort of a coherent end-to-end traffic management tool that'll allow you to focus on other things and utilize what's already in your stack, which is probably NGINX.
Yeah. I mean, if you already have NGINX in your stack and you've got the great services that people like NS1 offer, and we're trying to extend that by taking those extra metrics that are in the NGINX Plus product and be able to send that out to the GSLB providers so that you can make more intelligent decisions, not just based on the response time from the GSLB endpoint, but actually looking at what's actively going on in your environment and using those metrics to help.
Totally. And part of this too is, creating a repeatable process for deployment. The more you expand and the more that you need to scale, the easier it is to do so, right?
Nobody ever really thinks of DNS, and it's kind of good that way. You shouldn't have to be spending your time on DNS, and that's why people like NS1 make such a great platform for stuff like this.
Yeah, so in our next sort of phase, we're going to introduce you to the managed DNS platform in depth. We're going to do a full deep dive, talk about the filter chain and how we kind of put forth those pieces and being able to deliver something that's cost effective, that takes time off your plate and allows you to do other things, and also be able to achieve very complex setups with a couple clicks of a button or an API call. And then we'll also talk about how the agent is run along NGINX clusters, and Damian will discuss that. So as far as what you'll need a registered domain name. Most of you probably have that you're running. And you'll have a managed DNS account with filter chains added. We can talk with you after this presentation to get you signed up.
Yeah, and then obviously you need something to actually write that traffic to. So here we always say 3+ NGINX nodes because obviously you need redundancy. There's no point in having a GSLB unless you have multiple locations to actually balance that traffic through. And obviously we need to expose the NGINX Plus API to be able to collect those metrics. And then you'll need to have Go available on those machines because the integration is a Go-based solution.
NS1 also supports Go, so just FYI, end-to-end, you'll be good. So kind of giving you a primer on the managed DNS solution and kind of what differs us from something like a Dyna or Route 53. We're an anycasted network that is really designed for performance. Each one of you, if you all want to come up to me after the presentation and show me your phone, there's at least 2 or 3 applications that are already running NS1 to make sure that you get the information that you need quickly. The thing is that we're not based on bind. We are a proprietary name server technology that all of our co-founders wrote a few years ago that allow us to avoid some of the limitations that people typically run into with running their own open source version of that. A lot of the other managed providers in the space also kind of run up against this a little bit. We have 25 POPs around the world, including 5 super POPs, and these are all over-provisioned, DDoS protected, and again, anycasted. We have 100% API coverage for the entire platform. There are customers that I have worked with that have never seen the UI, and that's true for both our external product, which I'm talking about today, and our internal product. So you can do Terraform, Ansible, Go, Python, you name it, we can use it and be able to provide you the ability to kind of do this all within a terminal window. And our global change propagation on a bad day is 2 seconds. It's typically milliseconds globally. So if you need to shift traffic immediately, you send an API call, consider it done. Most providers in the space, there's typically, potentially a change window or a lot of other things that may become problematic as far as pushing changes through multiple teams. This allows you to kind of make sure that if you need to make an instant change, it's there. We have, again, services for redundancy and China-based use cases, in addition to latency-based routing and turnkey DNSSEC. Setting up DNSSEC with NS1 literally takes 2 minutes. You flip a button, we give you the information at the registrar, and we use a methodology called online signing that's fairly new. And we have the ability to do traffic management with that. And so geolocation, anything that you need to do with priority weighting would basically be able to be accomplished simply by also securing your zones. So let's talk about how we do that. So we have all this great technology. We're working with a lot of, colo facilities to deliver, the best managed DNS network possible. But it wouldn't necessarily just be that. We need to put forth the logic in which we have the ability to deliver people to the right place. And so we call that our filter chain. Typically, this is usually accomplished with a ton of code within bind that has to be hard-coded. It doesn't have any flexibility. We have the ability to take in static preferences like costs or commits, or we can take in telemetry and make an infrastructure-aware DNS product. And so things like availability, bandwidth, capacity, latency, all are things that we can take into account when routing users. Our geo-IP database is one of the most diverse in the world and some of the most granular. You have the ability to route based either on region, country, or even ASN number. And then we also utilize ECS information to be able to locate and identify and route appropriately. So these are just some examples of kind of the things that we can do within the structure. You can see that there's a DNS query coming in, and we have sort of these pieces of logic that can be applied in any kind of mass amounts to basically give the most intelligent, authoritative answer possible at any given point. What we're really thinking about doing here, though, is sorting, shuffling, or removing answers based on those statuses. Up, down has the ability to kind of tell us where, if something's responsive, and that can be with our built-in monitoring system responding to something like a TCP request. We have the ability to kind of take those real server time monitors, which is what we're talking about today with NGINX. Geo-proximity has the ability to either fence or target. So fencing has to do with only serving a specific answer to, say, a subnet or an ASN, and also geo, and then also being able to deliver people to the closest physical POP. And we'll kind of talk about my methodology with that in a second. And in addition to that, shedding load is something we're going to focus on in a minute, but that's taken into account sort of the telemetry and active connections and all of the things going on in those data center VPCs that you're using NGINX to monitor. And then sticky shuffle has the ability to keep in mind the user's initial request. If I'm requesting your application and I get sent to 76.120.78, whatever that is, and I request that application again, it'll continually send me to the same data center. Whereas if Damian makes that request, he'll get sent to 142. A different VPC perchance, and it'll remember his request as well. And so it keeps my cache happy, it keeps my interaction with your application happy, and it makes sure that you're still distributing traffic in a very even and balanced way, but still making sure that the end users are happy. And so what we end up arriving at is an optimal DNS answer. Now, these are just some of the examples. The amount of combinations that you can make are endless. A lot of what my team does is really take all of the problems that you're working with, on a daily basis, and being able to distribute traffic across, say, a hybrid infrastructure that you might be working with. You have, physical data centers, you have AWS AWS nodes and Azure nodes, and you also have, potentially CDNs that you might be working with, and being able to pull all that apart and come up with a routing strategy that'll really work for you. So one of the things that we use, we talked about sort of static weights and preferences, but what we want to talk about now is a little bit of the ingested telemetry that we can take in at the name server level and be able to determine whether or not a particular POP or location is healthy or not. So we have real-time metrics that allow for sort of that accurate routing capability. And a lot of the health checking that we're doing with this integration and others ensures that we're not sending users to a dead POP. A lot of the problems that people typically experience on the internet is, being misrouted, not having that sort of real-time connection, and manual failover is not something that you're going to do fast enough to not catch everyone. And so capturing all those measurements at the edge, you're already doing that. Why not use that to allow that to inform your routing policy? And so this is where the NS1 agent comes in.
Yeah, so there's so much that the NS1 does it on its own, but at the same time, it can. The big thing that we're adding with the integration here is that you can look at not only how is that specific endpoint responding, but what is actually going on with that endpoint. Is a certain site that's being hosted there overloaded more than other ones, so we can intelligently route away from that. Able to mark a system as offline before it actually goes offline. So if you start to detect an issue with the system, but it's still responding to requests, but maybe there's something underlying, it's not serving something up, the agent has the ability to send that notification to NS1 and say, no, this site's down. Stop sending us traffic. It may be responding, but it's not a good end user experience. So it's really about trying to get in front of that and hopefully detect the problem that you're seeing in your infrastructure before any end user actually sees that error. So that's really the key goal that we're trying to achieve here is just, NGINX is known to be fast and stable and all of that, but not always. Sometimes you have issues, and we just want to make sure that if those issues are happening, that you don't have that impact your end users.
Absolutely. And changing internet conditions are something that no one has any control over. And so you want to be sure that you have the ability to, again, not show that to your end users. Yeah. And so how do we deploy it?
Yeah, so again, it's very simple, really lightweight Go agent. It runs mostly on the current iteration of it. It's mostly going to be running locally on the NGINX node, pulling its statistics from the extended metrics API, and then taking that information, you just very simple config as you can see here. You can set all the intervals. You can set the host. Obviously here it's looking at the local host to pull the information, all the API endpoints. Obviously then you have to just put in your API key for your NS1 account, and then you can define the different information that you're actually capturing and sending to NS1, mostly so that you're not flooding them with information and you're picking the specific information that makes sense for your environment. There's no reason to send all of your metrics up there if you only care about one of them, because it's just going to add time and add latency and give you more of a chance of failure. So again, it's just really simple Go program, very little overhead. Like I said, currently we're in our first iteration of it. We're looking to expand the functionality, especially with the extended metrics that we just released in R19 will allow you to even have more granular information to send up there.
Great. So let's put it in practice. Let's talk through a couple of examples, because thinking about routing strategies, while theoretically speaking is great, it's good to visualize and kind of get our hands on kind of what we're working with here. And so the story that I think Damian and I both want to tell is, we've all worked at companies that have turned out very small and have had an explosion and have had a need to, set up data centers quickly, set up resources quickly, deploy things quickly, but you can't break anything while you do that. So we want to enable you to move fast, but not break anything, which is basically my methodology at NS1 in life. So let's talk about an easy filter chain. This is a small company. This is somebody that's getting started out. They don't have a lot of money to put into things like data centers or, deliverability, but they want to make sure that they, give the end users a distributed experience. We want to be sure that we're routing requests appropriately and that we're keeping in mind the load on all of our resources, simply because if something's down, we're basically down at this point, right? So we have a filter chain here that's specified, and the text is a little small, I apologize. But we have sort of shuffle, which is just going to work like a round robin. If you guys have worked with Microsoft DNS, it's going to do the same thing. It's just going to pick a POP no matter what. If it's configured as an answer on that record, we can see see that we have 3 data centers. We have Virginia, Ohio, and Oregon, effectively splitting the country up in, west, east, and central. And so we're just having all of these end users routed, just randomly to all of these POPs, and we're only selecting one. And so we have the ability to kind of put forth an easy chain. This can be implemented in literally less than 30 seconds. And this is really important to kind of keep in mind.
Yeah, and it looks, it's very simple. It's something that's been done with DNS for a long time. DNS load balancing is something that's been around, but this is obviously taking it to the next level, doing more intelligence in it, being able to take nodes out of that position. But again, we're just looking at basically just response time and what NS1 can see from the outside looking into your data center.
Absolutely. So let's get a little more complicated and probably a little more realistic on what you guys are working on a day-to-day basis. So this is medium. This is, we're a little more involved now. We have a little bit of money. We have the ability to kind of maybe put a couple of POPs in different regions and maybe route appropriately. And so you can see that the filter chain's added a couple of things. So we have the ability to geo-target regionally. And so that's a coarse routing capability. Given where our data centers are located, it's going to be good enough for us to be able to distribute traffic in each of those regions. And so we can see that we have North America, EMEA, and South America or LATAM. And we have all of these end users that are kind of requesting on different ISPs from different locations. And so what we initially do is, again, remember, we're sort, shuffling, or removing answers. And so geo-targeting is going to allow us to sort based on where the user is actually making the request from. We use ECS information. If someone's using a open resolver like an Open DNS or a Google, we're going to pass along that ECS information and get that very specific IP address where they're coming from. But even if they're using their ISP's DNS, that's good enough. We can get them to the right place. So we have the ability to kind of take that into account first, and then we can set a priority. So we can say, let's say that within North America, our Ohio data center, within EMEA, our Amsterdam data center, and within South America, our Sao Paulo data centers are extremely over-provisioned. They have the ability to handle, 10 times the traffic than you've hit at peak, and they have the ability to kind of, handle a huge load or a spike. Now, let's say we want to set the priority to have those be favored unless there is, for whatever reason, a disruption and we want to fail back to Santiago, London, or Ashburn, right? So we have the ability to kind of, again, just automatically do that. It's going to basically take over and send them to that POP without you needing to intervene.
Yeah, and again, we're looking at things that are externally available. We're not looking at information that's coming from inside those data centers. So again, we're getting much better, and you're doing a much more intelligent routing, trying to get your end users to not only the closest geographically, but the ones that are responding quickly. But again, we've always got somewhere better to go.
Exactly. And so let's look at Nirvana. This is what I like to call Nirvana. This is NGINX plus our Pulsar product. Which just to give you guys a little reminder, that's our latency-based routing solution that has the ability to take performance checks in real time from real-time users on the internet, making requests across different ASNs, and has the ability to do ASN plus geomapping to be able to locate people to the physically closest but also most intelligent answer. And so we can see the filter chains a little more diversified now. If you guys decide to work with us, you'll see that these can get quite long. But this is pretty relatively simple in NS1 terms, but we have an up filter. Up is simply just checking for availability. That's something that you can utilize our built-in monitoring system with. HTTPS, TCP, DNS. You can do all those experience tests to a particular location on a frequency that you choose from our super POP region. And then basically we have the ability to say whether or not North America, EMEA, or South America would be up.
And then also you have the benefit of that NS1 integration with NGINX can also send that down request. So it doesn't necessarily have to go offline. You can have logic on your data center level to say, nope, this node's offline, get it out of there.
100%. And then it brings us to the shed load filter. So shed load has the capability to take all of that data and telemetry from NGINX, and you have the ability to set a high and low watermark, which you can think of as like goalposts. You can think of as a low watermark as I need a minimum usage from this data center in order to keep it in rotation, and so we're making use of the resource that we've invested all this money in. But then I also need to keep in mind that I can't knock something over by overloading it with traffic for a particular network event or anything like that. And so we keep the traffic between both goalposts based on the information that's fed to us from NGINX. And if for any reason one of them reaches a certain point, we'll shift. The other thing that this can take into, or the three metrics that this can take into account would be load average, active number of connections to a specific POP or active number of requests. And so that's what the NS1 agent is really collecting and pushing to NS1, and we're basically being able to ingest. And then when we get to Pulsar sort, so this is, again, we've removed answers with the up filter, we've removed answers with the shed load filter if they're either overloaded or unavailable. And then Pulsar sort has the capability to say, okay, of these 6 answers, let's just say they're all still in rotation, which one of these is performing the best? And this is where I go on my rant about geo. So, sending somebody to the closest POP, while, realistic in some terms, isn't necessarily the best performance decision. Oftentimes there's a lot of internet conditions that come into account if you're using third parties like CDNs. They may be, a number of different providers may be having a different network event. And you also have to take into account ISPs, ASNs, all the BGP routing that all comes into account and being able to route traffic appropriately.
Just because the data center might be down the street from you doesn't mean that its network is behaving well that day, or there's not some other instance happening in the network in that general area. And it may seem with this basic routing, it goes, oh, here, you're closest to this, go there, but that may not be the best option.
Right, and so Pulsar has the ability to take those temperature checks for you, feed that into us and say, okay, actually, if this user is in Rome, it's actually both the EMEA data centers are having a moment. Let's send them to Virginia really quick because we're still at a sub 70 millisecond resolve time, right? So it has the ability to make those decisions for you, again, automatically. There's no manual failover here. There's no manual API call you have to make. You don't have to get into the system to make this change. This is all stuff that's happening behind the scenes, so you don't have to worry about it. So this is sort of our best case. This is really what we want you to walk away with of what's possible. And this is literally just the tip of the iceberg. So let's talk about just, again, benefits that you can use from this. Remote health checks, local capacity checks, capacity planning. All of you are sort of thinking about your budgets for the next year. Thinking about how you can basically drain traffic from POPs, plan for new ones, and also be able to automate all of that in the back end, right?
Yeah, and be able to look at that information and know, okay, this data center is getting hit hard, this data center, maybe you take all this information, you figure out one of your data centers just isn't stable and isn't good, and you can get out of there and get to a data center that, and invest your money where it makes sense. So you're not spending money on something that isn't being performant.
Exactly. And so, and I think the biggest thing that I really want to get across is that you shouldn't be doing manual failover unless it's like absolutely necessary.
And you shouldn't be worrying about your DNS.
Exactly.
Like, it's one of those things that most people don't understand. It's just magic. It just happens. DNS is just that, it's that thing you type in, or not even the thing you type in. You just click on something and it works.
Right.
People don't want to have to worry about this. But should still be intelligent. You don't want to be stuck using old bind. It's never any fun.
Absolutely. So just as a summary, I think these are sort of the main points that we both want you to take away from this. Automating your GSLB approach is kind of, it's 2019 and we need to kind of accept that this is sort of a new way in which we can apply, our logic, their very powerful product to be able to kind of create these complex rule sets that you can put in place that'll work for you. And creating a telemetry first approach. You're already collecting all of this data. You already have it. Yeah. Why not utilize it with something that can actually leverage it as a lever to be able to shift and steer traffic as needed? And be proactive. Like, set this up beforehand. So, setting it and forgetting it, I think, is the worst term ever. But when you really think about it, this is something that you should not be tinkering with on a day-to-day basis. I work with a lot of customers that, we're touching their DNS and each managed provider, daily. And that is not something that you should be doing. You should not be making these changes all of the time. It's something that you should be able to kind of effectively be able to manage with a simple API call if needed. And then, again, you're all writing applications, you're delivering them internally and externally, everything needs to talk to each other, and all of that is done with DNS. So again, making sure that you utilize it as a control plane is really what we want you to do.
Yeah, and at the end of the day, it doesn't matter how great your NGINX infrastructure is, if your DNS infrastructure isn't up to par with that, and you can have the best infrastructure in the world, if people can't get there, what good does it do you?
100%. And then, so we just have to throw this up because this is like, our thing. We don't just integrate with NGINX, we integrate with a lot of different partners that are really great, including F5 for all of you here. So, we have sort of a lot of different things that we can work with, ingest, and kind of utilize to shift traffic. And these are just some of our customers. Like I said, there's one of these apps on your phone right now that's literally running NS1. We can talk after the chat to kind of give you an idea of like what we might be able to do for you. But before that, I think we have 4 minutes left, and Scott's there with a mic. Do we have any questions? You got someone from NGINX and NS1. I mean, it's like, this is the best. Okay, yeah.
Hi, thanks for the presentation.
Sure.
So I'm from Cisco Umbrella. I'm
an ex-Cisco Umbrella employee. Hello.
kind of interested to know what the integration is about.
Yeah, great question. I mentioned earlier, today we're here to talk about the externally delivered solution, with NGINX. Hopefully we can bring that internally as well eventually. But Cisco Umbrella has the ability to apply all of their routing policies, security controls, content filtering, everything that you're doing internally already, to allow us to do the authoritative handoff. And so our private DNS product has the ability to, be the first hop in the line. Someone's asking for a request, I need to get to facebook.com. We notice it's not for the printer. And then we send it on to Cisco Umbrella to apply those policies and tag all of those requests coming from the specific DNS container. So you can apply policies based on that internal subnet as well as that container ID. So it's going to be built out. We are working with Cisco pretty closely on this. And if you have any questions about it specifically, you can come up and ask me. So anyone else? All right, I think we can end early. Thanks, guys.
Thank you.